All right, let's talk about fractions. Yeah, I know. For a lot of us, that word alone can bring back some, let's just say, stressful memories from math class. But what if I told you that all those rules and formulas aren't the real story? What if fractions are actually based on something we all get, something super intuitive, the simple act of sharing? So let's dive in and pull back the curtain on the hidden and surprisingly simple logic of fractions. Okay, so right off the bat, a quick question for you. Which is bigger, 1/5 or 1/9? Now, your first gut reaction might not be the right one. Go ahead, take a second to think about it. We're going to figure this out together. And you'll see how the answer cracks open the single most important idea behind all of fraction. All right, so let's start with this whole idea of sharing. The secret to getting fractions, it turns out, isn't buried in some dusty old textbook. Nope, it's in something way more familiar, something we do all the time, sharing a meal. And we're going to start with a simple roti, a flatbread, because really, that's all a fraction is. It's just a way of keeping track of how you share something equally. The number on the bottom, that's just how many people are in on the share. The number on top, that's how many pieces you're talking about. So if you've got one roti and you share it with two people, well, each person gets 1/2. See? It's that simple. So let's circle back to our puzzle from the beginning. Remember, 1/5 versus 1/9. The key to solving it, and honestly to understanding fractions in general, is this one idea, the unit fraction. Now, be honest. Did you think 1/9 was bigger just because 9 is bigger than 5? Hey, if you did, you're in good company. That is the most common mistake people make. But let's stop thinking about abstraction numbers for a second and go back to thinking about, well, those rotis. Okay, picture this. On one side, we take a single roti and we have to share it with 5 people. Everybody gets a piece we call 1/5. Now on the other side, we take that same roti, but this time we have to share it with 9 people. Each of them gets a slice we call 1/9. Just look at them. Which slice would you rather get? I mean, really? Yeah, exactly. It's common sense, right? The more people you have to share with, the smaller your slice is going to be. And that is the big reveal. 1/9 is actually smaller than 1/5. And just like that, you've solved the puzzle using real-world logic, not confusing math rules. And that specific type of slice, that single piece of an equal share, whether it's 1/2, 1/3, or our 1/9, that has a name. It's called a unit fraction. Think of it as the basic building block, like a single Lego brick for every other fraction out there. Okay, so comparing those single unit slices is pretty easy once you get the sharing logic down. But what happens when we're dealing with different types of slices? How do you compare or add them? It's like they're speaking different languages. We need to find a common tongue. Like, for instance, say you have 2/5 of a cake and your friend has 4/10 of a cake. Who's got more? And if you put your shares together, how much cake do you have? It's kind of hard to say at a glance, right? Because the slice sizes, the fifths and the tenths, are totally different. We need that common language. So to figure this out, let's just use a simple paper strip, super visual. Imagine this colored section here represents exactly 1/2 of the whole thing. Just keep your eye on how long it is. Okay, now what if we take that same whole strip, but this time we cut it into 4 equal parts instead of 2? If we take 2 of those fourths, check it out. The total length is exactly the same as our original 1/2 piece. They're the same amount, just with a different name. And we can do it again. Let's cut the whole strip into 8 pieces now. If you take 4 of those little eighths and line them up, yep, you guessed it, the exact same length. So what does this mean? It means 1/2, 2/4, and 4/8 are all just different ways of saying the exact same thing. And this powerful idea has a name, of course. It's called equivalent fractions. And this, right here, is our secret weapon. This is the common language we were looking for. It's how we can take any 2 fractions, no matter how different they look, and get them to finally talk to each other. All right, now that we have our common language, we can finally figure out the rules for combining fractions. And you'll see they're not scary at all. They're actually built on everything we've just figured out. Let's try adding something. We'll use another example, this time a sweet treat called a chickie. So, imagine you eat 1/2 of a chickie bar and your friend eats 1/4 of it. How much did you two eat in total? Now, we know we can't just add the 2 and the 4 on the bottom and call it a day. That wouldn't make any sense. So, let's use our new superpower, finding a common language. We know from our paper strips that the 1/2 piece is the exact same size as 2 1/4 pieces. So, we just swap it out. Instead of saying 1/2 plus 1/4, we say 2/4 plus 1/4. And now the problem is a piece of cake. 2 pieces plus 1 piece is 3 pieces. 3/4. And that's it. That is literally the entire secret to adding or subtracting fractions. All you have to do is make sure the pieces are all the same size first. You find that common language before you do anything else. So the official rule you learn in school is just a formal way of saying what we just did. Step 1, find a common denominator to make the piece sizes the same. Step 2, add or subtract the numerators, the number of pieces. Step 3, keep the denominator the same because the piece size didn't change. But get this. This method we just sort of figured out for ourselves, this isn't new. This is Brahmagupta's method, written down by an Indian mathematician way back in the year 628. How cool is that? And hearing that name, Brahmagupta, it just opens up this whole incredible backstory. It turns out these ideas that we still use in classrooms today have gone on an amazing journey through history and all around the world. In ancient India, for instance, the word for a fraction in Sanskrit was bina, and that word literally means broken or apart. So the concept was baked right into the language itself, this physical idea of breaking a whole thing into smaller pieces. And the journey of the fraction as we know it is just wild. So you have the first signs of writing one number over another showing up in India around 300 CE. Then, like we said, Brahmagupta nails down the rules for adding and subtracting in 628. But you know that little line between the numbers, the fraction bar? That didn't show up until the 12th century from a mathematician in Morocco. And it took all the way until the 17th century for this whole system to become the global standard we all use today. And this isn't us just connecting the dots after the fact. I mean, look at this. This is a direct quote from Brahmagupta's text from more than 1,400 years ago. He's literally describing how to find a common denominator and then add the numerators. It is the exact same thing we just figured out with our chickie example. That is just mind-blowing. So there you have it. We've seen how fractions, this thing that can seem so abstract and intimidating, actually grew out of the most human act imaginable, sharing a meal. And it evolved into this powerful system for thinking and calculating that's lasted for thousands of years. It really makes you wonder, doesn't it? What other parts of our modern world, the technology we use, the way we track time, are secretly built on these incredible, ancient mathematical ideas?